Hey there, Lorenzo here. I'll be starting a series on Apache Spark, and I thought a good starting point is to cover why we need Spark. For many people, Pandas is the entry point library when it comes to data analysis with Python, especially for engineers or people with non-computer science backgrounds. So Pandas is great, I've used it a lot in the past, but there are a few limitations. Pandas is designed to be run on single machines, and there's a limitation on the memory. It is purely for in-memory processing. So I will cover a very simple example showing Pandas and then covering the same example with Spark, and you will see that the example with Pandas, it will crash because we don't have enough memory to process the data frame. And you will see that in Spark, we will do it very quickly and it will be able to process it with no problem. So let's get started. Here I have my Azure Databricks workspace. I have my notebook for Pandas, and just to show you the compute here, I am using a simple one worker, one driver cluster configuration, and we have 16 gigas of RAM. So going back to the notebook, first thing we do, we import Pandas, and here I have a function to create synthetic data. Let's see how that looks. So we have 4 different columns. We have customer ID, we have categories, we have the amount and a date. Here we have 2 helper functions. One, it will allow us to look at how much memory is required to store the data frame, and the other one is the one that we will use to perform the analysis. Here we are going to do an aggregation by category, and we are going to compute the mean and the count. So if we take a look, let me run that cell, and now we take a look at different sizes for the data frame. Starting with 10,000 records, that uses 0.8 megabytes. And if we 10x that to 100K records, we see that the memory usage also 10x's to 8 megabytes. So right there we see that there is no memory optimization in Pandas. Memory usage will increase linearly with the number of records. Now, if we run the analysis, that group by aggregation for different sizes, that is where we are going to see interesting things, right? Because we have, again, going to the compute, we have 16 gigas of RAM. And if we start at 1 million records, that is 84 megabytes. But if we keep going, then 10 million will be 800 megabytes, and 100 million will be 8 gigas. And Pandas also incurs in some overhead. So we will see that if we start running this cell, we will see that we go through 1 million records, no problem. We start processing 10 million records, and we are already seeing some delays in the processing. And this is again because Pandas is designed to work on single machines. There is no distributed computing going on here. It is just one core and the memory available for that machine. So that took 0.6 seconds, and now if we start processing 100 million records, we'll see that the process here will eventually crash because we are running out of memory. I will wait, just for the purpose of the explanation, I will wait until this crashes, which should happen right around 2 minutes. But this is the reason why we need Spark. Whenever we are talking about large data sets, larger than the available memory that we have, we will need to use some type of distributed computing framework, such as Spark, where we have a cluster of nodes, a cluster of machines, and basically we have that pool of resources. And what Spark will do, the driver will be the one assigning tasks to the workers to complete, and the data will be partitioned. And that is how Spark will be able to work with very big datasets. So let's wait a little bit more until the process stops, just to show you that the process will eventually crash and I'm not making anything up. Let's see, it should happen soon. Here we go. So we see that execution failed again because we reach a limit on the memory available. Guys, so I realized I had a mistake on the recorded video. So here I am showing the same example that we saw in Pandas, but with Spark. So I'm using Azure Databricks, and here I have a simple cluster with just one worker. So here we are initializing, we are importing the library PySpark, and we have a very similar function to create synthetic data. So let me define that, and let's see how it works for just 100 records. Let me move this to the right here. And we have the same idea, right? Customer ID, category, then we have an amount, and then we have the transaction date. And for the analysis, we have a simple group by operation. We are grouping by the category, we are averaging the amount, and then we are calculating the count. So we are going to have 10 million records, 100 million, and then 1 billion right here. And we saw before that for 100 million, when we were using Pandas, the program crashed because it was trying to process everything in memory. So if I start this, we will see different execution times, and that makes sense, depending on the data, on the size of the data. So here we see that for 100, let me go up a little bit. So for 10 million we have 0.5 seconds, then for 100 million we have 1.7 seconds, and then for 1 million it took 15 seconds. So here we can see how Spark is able to process any type of data set, and the way it does it, it's by using a few different techniques. First, we are partitioning the data. In this case, since I have 4 cores, we are doing 4 partitions, and then when the data gets too big, larger than the memory of the executors, there will be some spilling into disk, and it is in this distributed fashion that Spark is able to work with any size of data. So that's what I wanted to show in this video. When data gets too big, larger than your memory in your computer, you will not be able to use Pandas, and you can use other distributed frameworks such as Spark. Follow this series for more videos on Spark, and hope to see you on the next one. Bye.